I wanted to show some examples of using InvNorm on the calculator with the standard normal distribution. In InvNorm, they'll give you the area and ask you to find the corresponding z-value. As in this example, they give the z-value there and say that the area to the left of it is 0.937. What is that value along the x-axis, which they call a z-value? Well, we're going to use the calculator and InvNorm, so it's 0.937. So on the calculator, I'm going to distribution, and it's this third one down here, InvNorm. And my stat wizard is on. That area is the area to the left, which is the 0.937. 0.937 for the standard normal, mean and standard deviation are 0 and 1. When I hit paste, it will calculate when I hit enter. About 1.53, 1.53. Let's see if the homework likes that. How many? Two places, 1.53, 1.53. Check answer. Fantastic. Okay, now let's go on. This is a normal CDF. Let me find another InvNorm one. This is a normal CDF. This is an InvNorm. The Z sub 0.03, this is what they call a critical Z value. And the 0.03 is the area not to the left of the Z value, but to the right of the Z value. The total area under the normal, standard normal curve is 1. So if 0.03 is area to the right, 1 minus 0.03 is area to the left, and that's what we're going to enter on the calculator. So on the calculator, again, I'm going to go to InvNorm. And this time the area is 1 minus 0.03, 1 minus 0.03 for the critical Z value, Z sub 0.03. The mean and standard deviation are still 0 and 1. And that comes out 1.88. Let's check that value. So two places at once, 1.88. Check answer. Nice work. Okay. Let's see what else they have here. Okay. This is a P92, the 92nd percentile means the Z value with an area of 0.92 or 92% to the left. Now, it looks like graph B here has area about 92% to the left. That looks okay, and then it's probably going to ask me for the calculation. So now it's the 92%, which is 0.92 to the left. So when I go to InvNorm, let me turn the stat wizard off so you can see how InvNorm looks without the stat wizard on. Okay, stat wizard off, enter. Let's get out of there. So what was it? P92, so 92%. So if I go distributions, InvNorm, now it's going to, my stat wizard is off, so I have to just kind of know what to enter. So it's 0.92 is the area to the left, comma, 0 is the mean, comma, 1 is the standard deviation, close the parentheses, and that gives me a value of about 1.405, 1.405, 1.405. Two decimal places, 1.405 would be 1.41 to two decimal places, 1.41. Good job. Okay, let's see. Let's see. Okay, well, let's do this one last one. So it wants us to separate the 3.1% that are the highest 3.1% and the lowest 3.1%. So the sketch here that separates these. I think it's D because the area, it's 3.1% to the left of that one, 3.1% to the right of that one. So I'm going to think it's D. Nice work. And then to find the actual numbers, now because of the symmetry of this graph, it's going to be the same value with a plus sign and a minus sign. So let's do, it's 3.1%, which is 0.031. Well, I'll show you to calculate both of them. So the one that has 3.1% to the left would be the lower value they're asking for. If I go distributions, InvNorm, 0.031 is 3.1% as a decimal. 0.031, comma, 0, comma, 1. That gives me negative 1.87 to 2 decimal places. And just to show the symmetry, if I do the higher one, which has area 3.1% to its right, that means it's 1 minus 0.031 to the left. So if I go distributions, InvNorm, 1 minus 0.031, comma, 0, comma, 1, that should give me the positive of that same number. And there it is. So it looks like plus and minus 1.87 to 2 decimal places. Is that what they want? 2 decimal places? Yeah, so it's negative 1.87, and it says use a comma to separate, and then 1.87. Let's check that answer. Well done. Okay.